Hello everyone. In our last class, we discussed types of lenses and convergent action of biconvex lens and divergent action of concave lens, right? Then here we are going to discuss terms related to lenses. Lenses means both the convex lens and the concave lens for both the lenses, right? First one, optic center. What is that? Optic center. It is designated with the O. Got it? Then one see the convex lens. Convex lens and concave lens. Convex lens and concave lens, right? Then midpoint. This point is called as optic center. Yeah. This point is called midpoint. Is called what? Optic center. Got it? Right. Then next term, center of curvature. Center of curvature. Center of curvature means the convex lens or concave lens, whatever it may be, is bounded by the spherical surface, right? Then the center of the sphere of its lens is called center of curvature. Got it? Then here, for example, see, this is one curved surface. Then let complete the sphere. Its center taken as center of curvature. Sir, here it has two centers, no? Two curved surfaces, no? Here this side. Complete it. Right? Then this side is also one, no? Say 2. Center of curvature 1, center of curvature 2. For mirrors, for curved mirrors, we have only one center of curvature. Why? Because it has only one curved reflecting surface. Here it has two surfaces or act as the refracting surfaces, right? It has both the curved surfaces. Got it? Right. Then so lenses have how many center of curvatures? Two center of curvatures called C1 and C2. Okay, C1 and C2. And in case of this is which lens? Biconvex lens. Here biconcave lens, right? Then here also one, see here this surface, see here this surface is one curved and this is also one curved. Then got it, right? Its center, this sphere is called C1 and this side is C2. Got it? It has two center of curvatures. And the next term, radius of curvature. Radius of curvature. We know that. What is radius of curvature? The distance between optic center to radius center of curvature, or one, right? The distance between this is R2. Okay, right? Here the distance between optic center to center of curvature R2 and this R1. Here one thing you have to notice, R1, R2. R1 means radius of curvatures. Radius of then lenses have two radius of curvatures. If a radius of curvature of first surface 1, second surface 2, maybe, may not be, may equal or may not be equal, right? Some cases for some lenses these two are equal, some lenses have not equal, right? Why? Because you will get some problems in examination. He will give while finding depending on the problem, some cases they will give then R1, R2s are indifferent. Lens maker's formula, he will give may different R values. There may you will get confused. No confusion. For the convex lens, may it has equal radius of curvatures or may not be equal. Not only in the convex lenses, in concave lenses also R1 may equal to R2 or otherwise R1 is not equal to R2, right? Based on this concept, which concept? Based on if the lens, if convex lens which has radius of curvatures are equal is called as equiconvex lens, right? If these are equal, if not equal, is simply we called as biconvex lens. Got it? Here in the case also, if a radius of curvature is equal for a concave lens, that is called as equiconcave lens. Concave lens, and different is called what, Nana? Biconcave lens. Got it? Got it? Based on radius of curvatures. Here we have classified based on radius of curvatures of a given lens, also splits into two types. If radius of curvatures are equal in a convex lens is called as equiconvex lens. If radius of curvatures are different, then such kind of convex lenses are called as biconvex lenses, right? Here in this case, then if radius of curvatures are equal, in case of concave lens is called as equiconcave lens, and if radius of curvatures are different, we call what, Nana? Biconcave lenses based on the radius of curvatures. Then got it, right? And here radius of curvatures of lenses also 2. Why? Because it has two center of curvatures, no, right? And one more thing, the line, the imaginary line which we drawn from center of curvatures C1 and C2, the imaginary line which we drawn from both the center of curvature C1 and C2, that line is called as what? Principal axis. Principal axis, right? Principal axis. When principal axis means the imaginary line which drawn by both the center of curvatures are called principal axis. This is one term, right? The next here we are going to discuss one more term. See here, in case of convergent action of biconvex lens, we discussed that. Okay, right. Convex lens, then this is principal axis, optic center, center of curvatures, right? Then if a parallel beam of light which is parallel to the principal axis, a parallel beam of light which is parallel to the principal axis is fall on convex lens. On which lens? Biconvex lens. After refraction, the refractor rays or meet at a point or converge at a point. This point is called as focus. What we call? Focus. Got it? Then same this side also it has a focus. Got it? Right? Then if a parallel beam of light which is parallel to the principal axis fall on the convex lens, it converges at a point. That the converging point is called as focus. What we call? Focus. Focus. Right? Then it is designated with the F. Got it? Then next term is focal length. Focal length. Next one is focal length. We designated with a small f. What is focal length? Very simple. The distance between optic center to the focus, optic center to focus is called focal length. This is okay. It is called focal length. Got it? These are the terms. These are the terms related to the lens. Here, optic center, center of curvature, and radius of curvature, and principal axis, focus, and focal length. And in the same case, the focus, finding a focus in concave lens, biconcave lens. Right? Okay. This is what? Biconcave lens. Right? Then this is principal axis, optic center, right? Okay, if a parallel beam of light which is parallel to the principal axis or fall on concave lens, biconcave lens, what happened to it? It diverges. It can diverge in different direction. In such case, how focus is found out? To find the focus, we have to extend backward. Right. When parallel beam of light fall on the concave lens, the refractor rays appears to emit from one point. Got it? When parallel beam of rays is fall on the concave lens, after refraction, the refractor rays appears to emit at one point. That point is called as a focus. In convex lens, if parallel beam of light fall on the convex lens, then they are meet at a point. They are really meet, they are appears to meet. Right? Got it? These are the terms are related to the lenses. Got it? Right. Next, one more important topic, that is rules to draw the ray diagrams. Rules to draw the ray diagrams. Okay. What are the terms we discussed here? And then optic center and the center of curvature and radius of curvature and principal axis and focus and focal length, right? Now here we are going to discuss rules of image formation. Okay, rules of image formation by lenses. Okay, to draw the ray diagrams, we have to follow some rules. Okay, first rule, rule 1, right? Here in case of convex lens, here we are discussing convex lens, right? Rule 1. What is that? If incident ray pass parallel to the principal axis after refraction, right? When a parallel beam of light fall on a convex lens. Okay, here always, then here convex lens can be represented symbolically like this. Always to draw this perfect sphere we may get little bit typical, no? So instead of that we can use symbolical representation of convex lens. This is a symbolical representation. So now I will show with the symbolical representation only. Okay, then convex lens, right? What is this? Biconvex. Okay, no, biconvex lens. Then principal axis, optic center, focus, center of curvature, okay, right. What is the rule? If incident ray pass parallel to the principal axis after reflection, what happens are, here after refraction it pass through the focus. We discussed in convergent action of convex lens. When parallel beam is falls, it refracts towards the focus, it passes through the focus, right? Got it? Here we have, right? If incident ray pass parallel to the principal axis after refraction, it pass through the focus. Got it? This is first rule. Okay, the rule 1, if incident ray pass parallel to the principal axis after refraction, it pass through the focus, right? Parallel to the principal axis after refraction, it pass through the focus. This is rule 1. This is rule 1. Next we are going to discuss rule 2. Okay, these rules are helpful in drawing the ray diagrams with the convex lens or concave lens. Okay, right? Rule 2 says that. What is rule 2? If a incident ray pass through the focus, if incident ray pass through the focus after refraction, so what happened to it? Okay, right, here again biconvex lens, right? Convex lens, principal axis, optic center, focus, and center of curvature, focus, center of curvature, right? Here what happened? The incident ray passed through the focus. Here incident ray is passing through the focus. After refraction, it passes parallel to the principal axis. Refractor ray passes parallel to the principal axis. After refraction, it passes parallel to the principal axis. Quite opposite to first rule or not? First rule, incident rays pass parallel to the principal axis. After refraction, it passes through the focus. Got it? Here, then incident rays pass through focus. After refraction, it passes parallel to the principal axis. Quite opposite to it or not? Got it? Right. This is rule 2. Here we are going to discuss one more rule, third rule. Okay, I have to add these rules to remember it. Okay, here rule 3. Rule 3 says that if incident ray pass through the optic center after it gets, how it travels, now I will show. Okay, this is biconvex lens, optic center, focus, center of curvature, focus, center of curvature. Got it? Right. If incident rays pass through the optic center, where it is optic center here, after it pass in the same line, so there is no deviation. There is no deviation. Got it? Right. See here, if incident ray pass through the optic center, after it pass in the same path and the same direction. That means there is no deviation. It passes straight when it is passed through the optic center. Got it? Right. These are the 3 rules. And at the same time, you can take if incident ray is passed through the principal axis. Here you can take both. Right. It is also travel straight. Why? Because the ray is act as a normal to the lens. Got it? In the 2 cases, in which cases, if incident rays pass through the optic center, and at the same time if incident rays pass through the principal axis, there is no deviation. They get refract, but no deviation. They travel in straight. Got it? Right. These are the rules related to the convex lens. Which lens? Convex lens. Now here we are going to discuss the rules of image formation by concave lens. Here you can take concave lens. That means by concave lens. Okay. Concave. Here rule 1. Rule 1 says that incident ray pass parallel to the principal axis after refraction what happened, right? See here, convex biconcave lens is symbolical representation is this. Actually we will draw like this, no, convex lens, this is what concave lens, this is concave lens. Concave lens symbolical representation is this, alright. Okay, see, optic center, focus, center of curvature. Got it? Got it, Nana? Okay. Then, if incident ray is pass parallel to the principal axis, after refraction, it is a diverging lens, no? It deviates in different direction, right? So in such case we have to extend it and it meet at a point focus. That means what we have to write? If incident ray pass parallel to the principal axis after refraction, it appears to pass through the focus. Got it? Or it appears to travel from the focus. It appears to emit from the focus. Got it? Right. Then this is rule 1. In rule 2, right, in rule 2, if incident pass through the focus, it pass parallel to the principal axis. Got it? Right, see here. Then this is concave lens, optic center, focus and center of curvature, focus and center of curvature. Got it? Then here it pass through the focus, right? Okay, it appears to pass through the focus, then it parallel to the principal axis. Got it? It parallel to the principal axis. This is in rule 2. Okay, right. It travels towards the focus, not it directly it is passing through the focus, but it passes towards the focus, right? Or either you can write if incident ray is passed towards the focus, right? After it passes parallel to the principal axis, right? If incident ray was towards the focus, it was parallel to the principal axis when after refraction. This is rule 2. And next and last rule number 3. Okay, if incident ray pass through the optic center after it pass in the same direction, that means there is no deviation, that means it travel in straight. Got it? Right, see here, concave lens, optic center, focus, focus. Then see here, the light ray which pass through the optic center, it is passing directly, and at the same time if incident ray is pass through the principal axis also without the deviation, on deviation. Got it? These are the rules. First rule, then if incident ray is pass parallel to the principal axis, after refraction it pass through the focus or otherwise appears to pass through the focus. Second one, if incident ray is passed through the focus, after refraction it is parallel to the principal axis. And third rule, if it is passed through the optic center, it travels undeviatedly, it travels in straight direction, in its same direction. Got it? These are the three rules. These are the three rules are very important. How to keep it in your mind, and in while drawing the ray diagrams, by using out of these three rules, we follow any two rules for complete the ray diagram. So thank you.